Morning, guys. Sorry again for getting my days mixed up. This would have been the do now work day, so I'll just kind of go through these. Just wanted you guys to try a few more of the radical equations. Um, for the first, if you want to, you can pause the video. Try them on your own as you would have in class, and then watch. But for number one, hopefully you recognize right off the bat that number one is a no solution. Remember that when it comes to these radical equations, if it's an even root, it cannot be negative. So this one's going to be no solution for number one. For number two, what you would need to do here to start this one off, it's a cube root. So because it's a cube root, the negative is fine. So this would not be a no solution. So what you would want to start off with here is squaring both sides. I'm actually just going to rewrite it. So for number two, we have the cube root of x plus 8 equals negative 3. And we'll start off by just taking both sides to the third power. Since it's a cube root, we're going to take both to the third power. And when we take it to the third power, again, a cube root and a cube cancel out. So it's just the x plus 8. And then negative 3 to the third power is negative 27. To continue to solve this, we're going to move the 8. And we end up with x equals negative 35. Again, you always want to, with these radicals, be in a thought process where you should always be checking. So if we go through and check this, we end up with a cube root of negative 35 plus 8 equals negative 3. This is going to be the cube root of negative 35 plus 8 is going to be negative 27. And the cube root of negative 27 is equal to negative 3. So this one is going to check. All right, for number 3, I'll move this one over here. Now, number 3 is going to be pretty much the hardest one you're going to come across with these radical equations. Equals root x plus 3. Now, for this one, if we go back to the rules we went over on Tuesday, I don't even know what day it is, I think Tuesday, our last session, we want to try to get the radical by itself. So here, if we try to move the 3, we would still end up with a radical over here with something on the outside, because we can't add things, again, as long as one is under the radical and one it's not, we can't just put a plus 3 and make it 11. So in this case, either side we move it to, we would end up with the situation where we would still have a radical. It's easier to leave it on this side with the root x only than to put it on the other side as far as the 3. So it doesn't really matter, but it's a little bit easier if we leave it on this side. So I'm going to leave it here and just go ahead and square both sides, because we can't get rid of the value outside of the radical. So we're just going to have to go ahead and square it. When we square it, again, when we have a root and then the corresponding power, they just cancel out. So it's just x plus 8. And on this side, just understand the difference. This is not this x plus 3 squared. If it was x plus 3, the quantity, like all together under the root, then in that case, it would be the same situation as the left side. This one is not. They're not together underneath the radical. So in this case, it's two different values, and we have to go through the process of squaring it. So we're going to have root x plus 3 times root x plus 3. And then we're going to go through the process of having to distribute this. So I'm just moving that down a little bit. So we have root x times root x. That'll be the square root of x squared. Root x times 3 will be plus 3 root x. Then I have to distribute my 3. The 3 times root x is 3 root x again. And 3 times 3 is 9. We would then come back and combine like terms. So we'd have x plus 8 equals. the square root of x squared. Remember, this is a square root, so remember we divide exponents, so that's just going to be x to the 1. So first, these two like terms come together. We'll get a plus 6x, 6 root x, and then the 9. All right, so now once we get to this point with number 3, we have to kind of again go back to step 1. Step 1 was to get the radical alone. So we still have a radical. This time it's here. Excuse me. And we still have to get that alone. So I'm going to do a minus x. Move the x away. That'll cancel out on this side. And it'll cancel out on this side. So I'll end up with 8 equals 6 root x plus 9. Still working on getting the radical alone. So I want to do a minus 9. I end up with negative 1 equals 6 root x. I would keep going. I still got to get that radical alone. Divide by 6. And I'm going to end up with negative 1/6 equals the square root of x. At this point, at this point, I have the same situation that I had in the beginning. I have a square root and I have a negative. This is no solution. Okay. I was about to say, anyone have any questions? Like, that's going to ask a question. But that is our do now. Alrighty. So moving back over here, let's get to the problems that we're going to do today. I will post the homework answers around 12 today. I'll just make sure you guys look at them. The only, well, obviously, if you have any questions, you can stop in. But the only one that I thought was different, per se, from what we did in the last class was number 12 from the homework. And this is number 12. The first problem that I picked for today is that number 12 from the homework. That was the only one we didn't do one like. All of the other ones were ones we did something like in class, etc. So for this, so for today, what we're going to do, again, we're going to continue solving the radical equations. We'll look at the harder types or the different types. And we're also going to start with the inequalities today. The inequalities aren't too much different from the equations, but they're slightly different. So we do want to take a look at those and not just assume that they'll be the exact same. So this is, again, the same as number 12 from the homework. And the first thing we're going to do here, again, we didn't have one where we had the complete problems under the radical on both sides. So this is similar to number 3, where we can't move anything. Don't think that because this is under the radical that we can do plus 7 and plus 7, since they're both under. You can't move anything as long as it's under radical. We need to first get rid of that. So to get rid of the radical here, what we're going to do is just square both sides. That's going to be our start here. So we're going to start taking both sides to the second power. When we square both sides, we end up with 2t minus 7 equals t plus 2. Then, after we've squared it, we have no more radicals. We just go about solving the equation. So in this case, we're going to do a minus t. We end up with t, or 1t, minus 7 equals 2. We add the 2. I'm sorry, add the 7. Add the 7. And we end up with t equals 9. Now that's our answer. Again, we always want to go back and check. So we have the square root of 2. I'm just going to skip the, writing out every single piece here. So I'm plugging in 9. So 2 times 9 is 18. Minus 7 equals 9 plus 2. 18 minus 7 is 11. And 9 plus 2 is 11. So I end up with root 11 equals root 11. and that is going to be true. So our answer checks, we're good to go. Again, the importance of checking these equations, the reason it's necessary is because once we square it, we are now looking at a different equation that we're solving. And it might work in, the regular form, but it might not work when we're in radical form. So that's the reason we have to always check these out. So number 2 is of the same caliber as number 1, where everything's under the radical on both sides. So this one is much easier than the one that was split, where we have, the root x plus 2, because we don't have to go through this whole process of distributing and etc. So when it's complete roots on both sides, again, we're just going to get rid of the radicals because we can't do anything else. And we square both sides. When we square both sides here, we end up with 3x minus 12 equals x plus 2. So now we've gotten to a point where there are no more radicals. So we just use the inverse operations to solve the equation. So minus x minus x. 2x minus 12 equals 2 plus 12. 2x equals 14. X is 7. To solve it from here, I'm sorry, not to solve it, to check it from here, we just, I'm going to do it on the side here for a quick check. So again, I'm just going to do the 3 times 7 in my head, so that'll be 21 minus 12 equals 7 plus 2. 21 minus 12 is 9. So I get the square root of 9 equals the square root of 9, and that's enough to know that it's going to check. All right. So number 3 is another one of the harder type, where you have to go through the longer process. So again, you guys should know how to do this one already. So if you want, just pause the video, try it on your own, and then come back and check the answer here. So we can't do anything for this particular problem. So we can't move the 4, anything. So with this particular problem, we're just going to approach it by squaring both sides. And just at least start getting rid of the radicals. So we'll end up with x plus 6 on this side equals root x minus 4 times root x minus 4. Again, when you square something, you have to multiply it by itself. It's not just going to be the individual terms squared. I distribute. When I distribute, I'll end up with the square root of x squared minus 4 root x minus 4 root x plus 16. Again, that's from my distributing, etc. I combine like terms. This is still x plus 6. On this side, I'll end up with x minus 8 root x plus 16. At this point in the equation, I have a radical over here, and I have to get it by itself. So to get a radical by itself, I do inverse operations as always. I end up with 6 equals negative, don't forget the sign there, 8 root x plus 16. Let's subtract the 16. I end up with negative 10 equals negative 8 root x. And then I divide by negative 8. My answer is going to be, I can reduce this first of all, so I'm going to do that. This will be 5/4. And the negative will cancel out and become a positive. So it's okay now because I'll have a positive answer here. So it's root x equals 5/4. All right, then I still have to square it because this is root x, I just want x. So I'm squaring both sides here. And I end up with x equals, when I square a fraction, it's just going to be 25/16. I have to square the 5 and I have to square the 4. So this is my answer for x. I still need to check this out, see if this will make any sense. So let's go do my check. On my check here, I have 25 over 16 plus 6. And I have the square root of 25 over 16 minus 4. So I'm just going to up here quickly do what this 25 over 16 is, plus 6 over 1. I need a common denominator there. Common denominator is going to be 16. Sorry, I'm trying to find my calculator. All right. And then 16 times 6, it should be 98. 16 times 5 is 80. I'm sorry, 96. That's still 25. All right. So then I'm going to go ahead and add those together. When I add those together, I'm going to get 121 over 16. So, yeah, that's just me adding these because I didn't have a common denominator. So now I'm just going to rewrite that down here. So I have 121 over 16 equals 25 over 16 minus 4. Now, when we spoke about the radicals and the division, I told you guys that you could separate this and make it like 121 over the square root of 16, and you could make this 25 over 16. The benefit of that is that all of these numbers are perfect squares. So now that I have this set up in this way, this ends up being 11 over 4 equals 5 over 4 minus 4. So at this point, it's clear to me that this is going to be a no solution. Well, these aren't going to work. Because we have 5 fourths minus 4, I know this is going to be a negative. Exactly what it is doesn't matter. It's going to be a negative, and this is a positive. So therefore, these aren't going to work out. I'm sorry, not these. This is not going to work out. This is going to be no real solution. Okay. Alrighty. So let's move on to the next thing. All right, so next we're going to start with the inequalities. The rest of the problems here today are going to be the inequalities. And this is the new piece that we're going to be adding. Now, pretty much with inequalities, not much is going to change. So when you see one, we're going to approach it essentially the same way we do the equations. We want to start off by getting the radical alone. So if we want to get this radical alone, we're going to start off by moving the 3. We end up with the square root of 5x plus 10 is less than or equal to 5. We then would do what we would do next. We want to clear the radical, so we would square both sides. Again, nothing's different for the most part in the process of solving. We end up with 5x plus 10 is less than or equal to 5. I'm sorry, 25. Subtract the 10. 5x is less than or equal to 15. Divide by 5. We get x is less than or equal to 3. So let's check our answer. Just like with the regular equations, we still need to check them and see if they're actually going to work out. So check. For my check, I have 3 plus the square root of. And I'm just going to go ahead and do 5 times 3 in my head. So it's going to be 15 plus 10 less than or equal to 8. So it's going to be 3 plus the square root of 25 is less than or equal to 8. So it's 3 plus 5 less than or equal to 8. That's going to work because it's 8. So we're good here. Check works. But this is where the situation changes a little bit. Excuse me. Now, this is not necessary when the x is on the greater than side. But when x is on the less than side of an inequality, you're going to have to determine what is the lower bound. Again, this is only going to be necessary when x is less than. So if you have x is less than or equal to some value, whatever it is, when x is on the less than side, this is going to be when this is necessary. And the reason for this is because if we leave this answer like this says x is less than or equal to 3. That means that according to this answer I just got here, that I could put negative 20 into here and it would be okay. So that would be 5 times negative 20 plus 10. And I would end up with the square root of a negative 90. And we know that that's not a real number. So this is the reason we need to establish this lower bound. Because if we leave it like this and just saying x is less than negative 3, then that means there's no cutoff. I can put in anything I want, negative 100, negative 2,000, and this would work. And in all actuality, we know that would not be true because we know that the thing underneath the radical can't be negative. So what we're going to do here is determine the lower bound, or what it has to be greater than. So in order to do that, we're going to take the expression, to set the expression under the radical equal to 0. Set the expression under the radical equal to 0 and solve. All right, so this is how we're going to determine that lower bound, that like cutoff. Okay, so when we're finding this lower bound, we don't care about the 3, we don't care about the 8, we only focus on the expression under the radical. So in this case, the expression under the radical is our 5x plus 10. So that's going to be the thing that we set equal to 0. So it's going to be 5x plus 10 equals 0. It's kind of like when we were doing the square root functions, and in order to figure out the restriction on x, we had to take the thing under the radical and set it equal to 0. That same idea is what we're doing here. So we subtract the 10. We end up with 5x is equal to negative 10 divided by 5. We get x is equal to negative 2. So this is our lower bound. So what we do is we're always going to, so we're going to have to extend this here, and x is going to have to be greater than or equal to negative 2. The answer to the equation, the inequality, would be this full answer. It's not just less than 3. That's what we got from the solving. But again, we need to stop it at 0. So we create that lower bound by setting the thing underneath the radical, the expression underneath the radical, equal to 0. You always are going to need that lower bound. If it's less than, I mean, I say always, we're going to need it always if it's less than. If it's greater than, it doesn't matter because it's x is greater than something. So we're not worried about any negatives possibly being plugged in and etc. But if it's less than, that's necessary. All right, let's try a second example, number 5 here. All right, so for number 5, guys, again, in the beginning, nothing's going to change at all from just solving what we were doing with the equations. So we're just going to move the 1, subtract the 1. We end up with the square root of 2x plus 2 is greater than or equal to 4. We square both sides. We end up with 2x plus 2 is greater than or equal to 16. Radicals are cleared, so now we just go ahead and solve it. Subtract 2. 2x is greater than or equal to 14. Divide. We get x is greater than or equal to 7. Take a second, do a quick check. I'm trying to make the video a few seconds shorter. So this will end up being 4 plus 1 is greater than or equal to 5. 5 is greater than or equal to 5. It's going to check. So we're good. Our answer is great. Move on. And I'm sorry, let me state this. This one is a greater than situation. X is greater than 7. So when it's greater than, again, we do not need a lower bound because it's not going to go into the negative realm. We wouldn't ever plug anything negative in to worry about having to create a cutoff. All right, so let's look to number 6. All right, number 6 is square root of 4x minus 4 minus 2 is less than 4. So again, in the beginning, we do it just like we do an equation. We add 2. We end up with the square root of 4x minus 4 is less than 6. We would square both sides to clear the radical. 4x minus 4 is less than 36. And we get x is less than 10. Hopefully everyone's fine with that. All right. Now we're going to check it. Over here, I'm going to set this up for a check. All right. So started the check here. So once we get to this point, hopefully everyone got to the square root of 36. Minus 2 is less than 4. I go ahead and take the square root of the 36. That's going to be 6 minus 2 is less than 4. 6 minus 2 is 4. 4 is less than 4. Now, a few of you might think this is a no solution, and I would understand why, because 4 is not less than 4. But what you have to remember here is that it's not saying that the answer is 10. It's saying that the answer is less than 10. So since you have 4 equals 4, if I plugged in something that was less than 10, like 9, etc., then you would see that it would be less than 4. So because this is equal, anything less than would work. So this kind of checks. I don't know how to really better than that. Again, I know technically this might not look correct, but it is going to work because we're only going to put in things that are actually less than 10. So this answer is okay for me. All right, but now again, I have to worry about this lower bound. I didn't have to worry about it for number 5 because that was greater than. But here for number 6, again, I'm going to have to worry about the lower bound. Again, this lower bound is only necessary when it's less than. And that's because since it just says less than 10, that means that I could have come in here, if I see this, and I can put in negative 8, and it should work. And that's not true. So we have to accommodate for that and put a lower restriction on it. So for this, I'm going to, again, take the expression under the radical and set it equal to 0. All right, so in this case, this is going to be our 4x minus 4. So it's going to be 4x minus 4 equals 0. And I solve. I end up with 4x equals 4. I end up with x is equal to 1. That's my answer here. So that's going to be my lower bound. So I'm going to, on this side, it's always going to go on the lower side, on the other side, because it has to be greater than that. And it's going to be x is greater than or equal to 1. And it's always greater than or equal to, because it can be 0. It just can't be, less than that 0. So it's always going to be greater than or equal to. All right. Here's number 7. Number 7 is another less than situation. So again, whenever it's less than, we should be always thinking of the lower bound. that we need to establish. So plus 2, we end up with the square root of 3x plus 9 is less than 9. Square both sides. I end up with 3x plus 9 is less than 81. $72. 5 by 3. I end up with x is less than 24. All right, and then I want to check this answer. So over here, let me do my quick check. Again, when you get over here to the check, again, we have the same situation where we end up with like 7 is less than 7. Again, that's not right ideally, but because we know it's less than 24, the actual thing would be plugging in. This will end up working out, so you're fine with this being an equal to here, because it's not like you're actually going to put in 24. It has to be less. So again, this is a less than, so we do require the lower bound. So over here on this side, I'm going to determine what my lower bound is going to be. Again, I take this value under the radical, that whole entire thing, and I set it equal to 0. Subtract 9. End up with 3x equals negative 9. End up with x equals negative 3. So our x is going to be, I'm going to add this on here. It's always greater than or equal to the negative 3. All right, guys. Let me see if there's anything else underneath we need to do. There's another greater than. I'll go ahead and post this one. I'll just finish this real quick. I think it's this last one anyway. So plus 6. It's going to be square root of 2x plus 14. Again, we want to get the radical by itself. Greater than or equal to 10. I'm going to square. I end up with 2x plus 14. Greater than or equal to 100. 2x is greater than or equal to 86 when I subtract the 14. Divide by 2. X is greater than or equal to 43. Again, greater than do not require a bound, a lower bound, because it's greater than something. And I don't have to worry about it becoming negatives. If I go over here and check with a quick mental check here, I know that 43 times 2 is 86. 86 plus 14 is 100. That'll be the square root of 100. Minus 6 is greater than or equal to 4. 100 is 10 minus 6. So this will be good. All right. I'll show you guys the exit card. Someplace here. That'll be the answer for that will be on the exit card. I mean on the notes from today. Here is the exit card. If you guys want to get started on this, there's 2 equations and 2 inequalities. So you guys are good to go. Have a great day. Sorry this video is so long, and again, sorry about today. I don't know how. I thought it was an A day. Beats me. Have a great day. Bye.